Hi, hello, welcome back to my channel Civil Ka Adda. So those who have not subscribed to my channel, please do subscribe to my channel Civil Ka Adda. So in this video, I am going to explain about how to design a dog-legged staircase. So watch the video till the end for better understanding. I am going to explain each step by step with proper understanding and proper explanation. So watch the video till the end. Don't think that the video is lengthy. I am explaining each step by step and as per the codal provisions. So before going into the solution, we'll say the question first. So design a dog-legged staircase for a building in which the height of floor is 3.3 meters. Adopt rise and tread of each step are 150 mm and 225 mm respectively. So the stair hall is 2.5 meters by 4.5 meters and live load may be taken as 3 kilonewton per meter square and use M20 grade concrete and Fe415 grade steel. So assume the stairs are supported on 230 mm walls at the ends of outer edges of landing slab. So this is the question. So he has given this given data and he is asking to find out the complete design of a dog-legged staircase. So we'll see how to solve it. So the first step, as usual, whenever we are solving the problem, you need to write whatever given in the question, that to be written first, so that you will be understanding what is given and what to find out. So based on that given data. So what is given in here in the question? So the height of the floor is equals to 3.3 meters. R rise is equals to 150 mm and tread T is equals to 225 mm and live load is equals to 3 kilonewton per meter square and FCK it is 20 newton per mm square and Fi 415 newton per mm square and thickness of the wall is 230 mm and the dimensions of this stair hall is 2.5 meters by 4.5 meters. So this is given. So we'll see the first step. So after writing the given data, so proportioning of stairs. So we need to find out how many number of rises are there, how many number of treads are there, that we need to calculate it. So height of one flight. So height of one flight is equals to height of floor by 2. So 2 flights make one staircase. So that's why height of floor by 2 will give the height of one flight. So height of floor is how much? 3.3 meters. It is already given in the question. And by 2 will give the height of flight. It is 1.65 meters. So now based on this height of flight, we need to find out the how many number of rises need to be provided and treads. So number of rises is equals to height of one flight by rise. So height of one flight by rise. So height of one flight how much? 1.65 meters, so which is 1650 mm. By rise is 150 mm. So 1650 by 150 is equals to 11. So number of rises is equals to 11. So now we'll find the how many treads. So number of treads is equals to riser minus 1. Riser minus 1. So it is 11 minus 1. So why we are taking like that? So I'll explain here. So one rise, so tread here and another rise, right? So 2 rises are there and 1 tread is there. So 2 treads are there. So 3 treads are there, 4 rises are there. So rises minus 1 will give the number of treads. So 11 minus 1 is equals to 10. So now number of rises are 11 and number of treads are 10. So based on the dimensions of the staircase, so it is 2.5, right? So assume the width of the stair. So adopt the width of the stair as 1.2 meters. So width of the stair is 1.2 meters. So we want the length required for that particular. So for 10 treads, So the length required is equals to 10 into tread. So that is 0.225. So 10 into 0.225 meters, so it is 2.25 meters. So the tread length is equals to 2.25 meters. So width of landing is equals to, so this dimensions, we know this dimensions of the dogleg already given, the hall it is 4.5 by 2.5, right? So 4.5 minus 4.5 minus 2.25. So that is here to here. So this point to this point. How much it is? 1.125 meters. So for complete tread, this one. So overall is 4.5 minus 2.25. So that will give the landing width by 2. So here. So then it is equals to 1.125. So 1.125 is the width of landing. So what we have did, this I will explain again. 4.5, complete 4.5 minus this 10 treads length, 2.25 by 2. So then you will be getting the width of the landing. So that is 1.125 meters. So see here. So the steps are arranged here. So 1.125 is the width of landing, what we have calculated just now. And this is 2.25 is the 10 treads length. And again 1.125, and this is the wall thickness. So already it is given 230 mm. So it is 0.23 meters. So complete here dimensions 2.5. So we have assumed width as 1.2, right? So this is the arrangement of steps. So we'll move to the further step after finding this all proportions of stairs, proportioning of stairs. So we'll move to the second step, effective span. So in some questions directly they will give the stairs, so steps arranged, and they'll ask to find out, they'll ask to design. So from then you can start from here after taking the given data and everything. So in this question they have not mentioned, so we need to calculate it. So effective span. So as the stair slab is spanning longitudinally, effective span is equals to center distance of wall. So that is 0.23 by 2 plus 4.5 plus 0.23 by 2. So let me explain that. So this is 0.23, right? So 0.23 by 2. So from here, this center to this side center. So 0.23 by 2, this is 0.23 by 2. Or else 4.5 plus 1, 0.23. So 0.23 by 2, 4.5 plus 0.23 by 2. So then we will be getting the center to center distance. So that is equals to 4.73 meters. So now thickness of slab. So what is the thickness of slab? We'll find out. We have calculated the effective span. So we need to calculate the thickness of slab. So we can assume the effective depth by span by 20 to 25. So you can take D is equals to span by 25. So span is how much? 4.73 meters, which is 4730 mm. By 25, so which is equals to 189.2 mm. So adopt D is equals to 190 mm and add cover to it, and overall depth is equals to 220 mm. So after finding the thickness of slabs, we are calculating the loads. So what is the complete load? WU we need to find. So we'll see that clearly in this step. So to calculate the complete load, there are different steps we need to calculate. So that is loads per meter horizontal width of stairs. So we are taking it for 1 meter. So weight of waste slab, so which is given as D under root 1 plus r by t whole square into 25. So density of RCC, unit weight. So which is equals to 0.22d under root 1 plus 0.15 by 0.225. So rice and threads whole square into 25. So it is given as how much? 6.61 kilonewton per meter. So to find the load, complete load, we want the waste slab weight and also steps and the live load, and we can take the floor finishes. So then it will make a complete total load. So weight of steps is equals to 1 by 2 into r into 25. So r is the rise, 0.15. So if you calculate that, 1.875 kilonewton per meter square. So live load is already given in the question, 3 kilonewton per meter square, and assume the floor finish 0.6 kilonewton per meter square. So you can assume this floor finish, you can take the floor finish 0.5 to 1. So I have taken 0.6 kilonewton per meter square, so you can take it as 0.5 to 1. So 0.6 kilonewton per meter square. So total load is equals to all this. So for your clear understanding, I have made it as the points. So sum of all this will give the total load. So W is equals to 12.1 kilonewton per meter square. So this is the working load. So we want the factored load or design load, right? So it is multiplied with the partial safety factor. So partial safety factor is 1.5. So factor load WU is equals to 1.5 into W. So 1.5 into 12.1 will give the total load. So that is the factor load WU is equals to 18.15 kilonewton per meter square. So that is the total factored load. So now we'll see the bending moment, factored bending moment. So it is uniformly distributed load, right? So simply supported. So WU is equals to WUL square by 8. Sorry, MU is equals to WUL square by 8. So bending moment. So WU just now we have calculated 18.15. So L you know 4.73. So that's center to center distance. So square by 8 will give the MU. So which is equals to 50.76 into 10 power 6 Newton mm. So don't think that the problem is lengthy. I have written clearly. I have taken the distance. So don't think that the problem is lengthy. If you solve it, very easy. So you'll be understanding it very easily if you solve it by step. So minimum depth required. So whatever we have calculated the depth already in the previous steps, we need to check it for the minimum depth requirement as per our codal provisions. So the minimum depth required to resist bending moment. So MU is equals to 0.138 FCK BD square. So 0.138 FCK BD square, this is based on Fe415. So as we have Fe415 given in the question, so it is 0.138 FCK BD square. So substitute all the values, you know MU, you know FCK. So B we are taking it for 1 meter, so 1000 mm, so D square. So calculate D. So D is equals to 135.6 mm. And whatever D we have calculated is how much? 190 mm. So 190 is greater and 135 is less. So therefore the minimum depth required, it is satisfying. So we have taken 190 mm. So it is satisfying the minimum depth required as per our codal provision. So hence provided depth is adequate. So we can move to the next step. So calculating the tension reinforcement. So what is our main intention? How much distribution reinforcement is required? How much main reinforcement is required? And what is the center to center spacing for that reinforcement bars? Right? That we are doing. So for that we want MU. So to get MU, so we want WU. So that's what we have calculated. So it is like stepwise. It is not unit. You should not buttify that after this step. No. So we want this MU. So WUL square by 8. So we want WU. So like that. If you go back, you will be understanding it. So coming to the next step, tension reinforcement. So as per our page 96 IS 456 2000, MU is equals to 0.87 FIAST D into 1 minus FIAST by FCK BD. So this is from page 96. So substitute all the values. You know all the values except the AST. So D you know 190, FI you know, MU you know, FCK you know, B you know, D you know, everything you know except the AST value. So that's what we need to find in this, right? So AST you need to find out. So substitute all the values. So first write down this, and after that calculate this, and after that calculate this. So this into this will give this value, and this into this will give this value. So here AST, and this is AST into AST, AST square. So bring this to left hand side. So plus, and this will be minus, and this is already here, so it will be same. So which is equal to 0. So make this equation and make it as equal to 0. So find out the AST. So find out the AST, and so use 12 mm diameter bars. So we are taking 12 mm diameter bars for tension reinforcement. So assuming 12 mm diameter bars, and spacing of bars should be calculated. So spacing of bars is equals to small AST by capital AST into 1000. So small AST is pi d square by 4. So D already you know 12 mm. So substitute that. AST also you know, substitute that, and you'll be getting the spacing of bars for tension reinforcement. So S is equals to 139.29 mm. So hence provide 12 mm bars at 130 mm center to center. So this is tension reinforcement. So we'll see how we need to provide the distribution reinforcement, how much we need to take it. So what is the center to center spacing of the bar? We'll calculate now. So this is the last step. So AST is equals to 0.12% of gross area for distribution reinforcement. So 0.12% into area, 1000 into 220. So overall depth here. And AST you will be getting 264 mm square. So using 8 mm bars, so spacing of bars is equals to same AST by capital AST into 1000. So pi by 4 into 8 square by 264 into 1000. So you will be getting the S. If you substitute all this, you will be getting the spacing, which is equals to 190.4 mm. So hence provide 8 mm bars at 190 mm center to center. So this is the distribution reinforcement. So we'll see now the last step. So after finding the distribution reinforcement, you need to draw the details of reinforcement, whatever you have calculated till now, right? So the details of reinforcement. So draw the dog-legged staircase and mention all the dimensions. So landing dimensions and complete stairs, stair length, and 230 mm thickness of the wall. And this is the overall depth, 220 mm. So this is the 230 mm thickness. And the main reinforcement and distribution reinforcement. So main reinforcement is 12 dia at 130 mm center to center, and the distribution reinforcement is 8 dia at 190 mm center to center. So which means we are done with the problem. So whenever you're solving any problem, so you need to last step, if you draw the details of reinforcement, whatever you have calculated, then by seeing this complete figure, you can easily knowing the main reinforcement and distribution reinforcement values. So what is the dia, what is the center to center distance. So thank you for watching the video till the end, and please do like, share and subscribe to my channel Civil Ka Adda.